Alright guys, welcome to your Unit 3 Quiz 2 Study Guide video. Let's begin your number 1. I think I'm going to be doing the even problems. For number 2, we want to find this limit. Now, when you're doing a limit, technically you're always supposed to start off by just doing some direct substitution. So if it works, if you just get an answer, then it really is just that easy. So let's go ahead and see if this one really is just that easy. Oops, that's a 3. So we end up with -1. Now the cube root of -1 is -1, and since there's 2 negatives there, the final answer is 1. So there's my answer. So if you could just plug a number in and get an answer, then that's your limit. And that's called direct substitution. All right. Let's go ahead and move on to number 2. Now, another thing you guys are going to be seeing is you're going to be seeing these absolute value functions. Okay, so we need to know how to turn these into piecewise functions, right? So the steps that I gave you guys on the video is to take the part that is inside and set it equal to 0 and solve for x. Now, in this case, I don't need to solve for x. X is already solved for, all right? But we do want to do like a little number line test here. So we have the left side and we have the right side. So if I were to plug in -1, would that change the sign? Yes, it would. It would become a +1, right? Likewise, if I were to plug in a +1, would it change the sign? The answer is no. All right, so now that tells us which ones we're going to change the sign of and which ones we're not. So here's my piecewise function. For anything that is less than 0, we're going to change the sign. So we have -x plus 3, but I'm going to change the sign to a +x plus 3. And since it's just positive, we might as well not even have it. So really it's just x plus 3, right? All right, and anything that is greater than 0, or anything, in other words, anything over here, it's going to stay the same. The difference is we just don't need the brackets anymore. All right, so there's that. So there's my piecewise function. Now I want to find the limit of this thing as x approaches 0 from the left. Now if I'm approaching 0 from the left, that means I'm using this one. So the limit as x approaches 0 from the left of negative absolute value of x plus 3 is going to be equal to the limit as x approaches 0 from the left of this top piece. And then from there you can just do your direct substitution. And there's my answer. Let's go ahead and do another one here, number 4. And you'll notice that this one doesn't have a plus and or a minus here. So that means we need to do both. We need to do the left and the right. And when that happens, you have to make sure that they equal the same thing. If they equal the same thing, then that's what the limit is. If they don't equal the same thing, then that's not what the limit is. So let's begin. So we start by taking the inside of the absolute value, setting it equals 0, and solving for x. So I get 3. We do a little number line test, and we pick a number that is less than 3 and plug it into up here. So let's go ahead and do 0 minus 3. And then we pick a number greater than 3, plug it in here. On this side, it will change the signs, because 0 minus 3 is a -3, and the absolute value will change the sign. It will not change on this side. So piecewise function then will look like this. For anything less than 3, we change the signs. So instead of being -x minus 3 minus 1, it's now +x minus 3 minus 1. And for anything greater than 3, the other side of my graph, we don't change the sign, so that one's going to stay negative. All right. Now I want to know what is the limit as x approaches 3 of the absolute value of x minus 3 minus 1? Well, since it's not a plus or a minus here, it's both. So we need to do both of those. So I need to find the limit as x approaches 3 from the right. And I also need to find the limit as x approaches 3 from the left. Now, if I'm approaching 3 from the right, that's going to be this bottom piece here. And if I'm approaching 3 from the left, that's going to be the top piece. If these two things turn out to be equal, then we're in good shape. So let's see how this goes. I'm going to plug in 3. 3 minus 3 is 0, and 0 minus 1 is negative 1. Plug it in here. 3 minus 3 is 0, and 0 minus 1 is negative 1. Those are equal, and since those are equal, we know that that limit must be negative 1. So, voila, we're all done. All right, so last problem, we had to do only one side. If they don't have a plus or a minus, you got to do both sides. All right, go ahead and take a look at yet another absolute value problem. All right, I think I'll skip number 5 and let you guys do that one, but I'll go ahead and do number 6. So we'll begin doing the same thing we did before. We take the part that's inside of the square root, set it equal to 0 and solve. Number line. Pick a number to the left and plug it into the absolute value for x. And a number to the right of 2. And once again, we can see there's a change on this side, but no change on that side. So, let me go ahead and write our piecewise function here. It's going to be for all x that's less than 2. We're changing the sign. So it's going to be 2x minus 4 over x minus 2 with a negative in the front of it. And then for all x greater than 2, it won't be changing. Just stay the same. All right. Now these ones are kind of special. They require an additional step. As you guys can see here for the top here, if I were to factor out a 2, on each of these problems here, you'll notice that these cancel out, and it leaves us with the following. This is just 2 over negative 1, which is negative 2, and this is just 2 now. So for all x less than 2, we have a negative 2, and for all x greater than 2, we have a positive 2. So that's the simplified version of the whole thing there. You're going to be doing something similar on number 5, but for number 6, there's a little bit more work here because it's just asking me to find the limit. On number 5, it's asking you to find the limit only from the left, but this one wants the limit, which means I actually need to do the limit from both the left and the right, and I need to see if they match up at the same spot. Okay, so we have the limit on the left of this function, and then we also need to find the limit on the right of that function. And then we want to see, do they come out to be equal? If they do, then that's my limit. If they don't come out to be equal, then it's not. Well, if we're finding the limit as x approaches 2 from the left, that would be this piece, so it's simply negative 2. And for finding the limit from the right, that would be where x is greater than 2, so that would be this piece. Now, there's nowhere to plug these numbers in here, so that means that these are simply our answers. We have negative 2 and 2. And as you can see, these are not equal to each other. So the left and right hand limits are not equal, and therefore we would say this does not exist. Okay. Now, if I were to, let's say we go back to the very beginning, if I just had a negative here, then my answer would have been negative 2, because that's from the left. Or if I would have had a plus here, then that would have meant we're finding the limit from the right, and that would have been this one. So, but if just asking for the limit, you have to do both. All right, let's move on to the next one here. All right, so on this one, we're going to try to find our limit. So let's try some direct substitution here. So if I do direct substitution, we get 1 minus 3 plus 2 over, and that ends up giving me 0 over 0. Now, just so you guys know, we're not supposed to put equals 0 over 0, but that just means direct substitution fails because that's an undefined expression. Okay, so we need to remove that discontinuity somehow, and that we've learned 3 ways so far to remove discontinuities. This one is going to be the method that involves factoring. So here we go. Factor this guy here. So I'm not too sure how you guys choose to factor here. Oops. But let's review it a little bit. So we ask ourselves, what 2 things multiply together to make x squared? Well, that would be x times x. And what 2 things multiply together to make 2? Well, that would be 2 and 1. Now, we have to FOIL this out to see if it'll work. So let's try that. That'll be x times x is x squared. X times 1 is x. 2 times x is 2x. And then 2 times 1 is 2. And then if I simplify that, I get 3x. Now this is close. It's not quite right though, right? Because we want a minus 3 in the middle. So that's an easy fix. Sometimes it's an easy fix and sometimes it's not. In this case, it's pretty easy. We're still going to have x times x making x squared. We're going to have 2 times 1 making 2, but we can make them both negative because negative 2 times negative 1 also makes a positive 2. So, but that, when we expand it out, will give us what we want. X times x is x squared, x times 1 is negative x. Negative 2 times x is negative 2x, and then 2 times negative 1 is positive 2. And so we have that, and that's the good one. So that's what we want. So the factored form would be this. So my numerator then is going to look like the following. I'm going to write it in factored form. And a good hint, by the way, if you're factoring it right, so you don't have to do so much guessing and checking, is look at the bottom. I mean, whatever's down there, that's probably going to be one of your factors, because the whole point is the next step, they cancel out. If they weren't exactly the same, they wouldn't cancel out, right? So it kind of helps you pick a little bit. But anyway, step 1, factor. Step 2, cancel. Step 3, try your direct substitution again. And that gives us negative 1. Final answer there. So factor, cancel, plug, right? Let's go ahead and move on to number 8. I think I'll leave number 8 for you guys to do there. The answer, though, if you want to check it, is 1/2. Okay? And I think I'll skip 9. I'll let you guys do 9, but I'll do number 10. All right, so direct substitution, what will that give me? Plug that in there. I'm going to get 1 plus 8, which is 9, and the square root of 9 is 3. And then 3 minus 3 is 0. And then plugging in 1 here, I get 0 again, and that's indeterminate. So we can't, in other words, direct substitution doesn't work. So what do we do now? Well, with these kinds that have the radicals, we don't factor. What we do is we multiply by the conjugate. Now, the conjugate is going to be, find the part that has a square root in it. That's this part up here. And what we're going to do is we're going to multiply that whole thing by itself, but with one little difference. The difference is instead of a minus being right here, we're going to put a plus there. And whatever you do to one side of your fraction, you're going to do to the other side as well. Okay? So, let's go ahead and clean that up a little bit. All right. Now, on the bottom, then we're going to have x minus 1. And then we're going to have this whole thing as well. On the top, when you multiply 2 conjugates, instead of foiling it out, you could really just do the first times the first. And when you do that, since they're identical, it just cancels out the root. So you're just left with what's under the root. So it's just x plus 8. And then you do last times last. Negative 3 times positive 3 is negative 9. And then we're going to simplify that expression. X plus 8 minus 9 is x minus 1. And as you can see, the x minus 1s are going to cancel, leaving me with nothing on the top, but we don't put nothing there. We actually leave a 1 there. And so that's going to be square root of x plus 8, 3 there. And now we're ready to go ahead and do our direct sub. So plug in your 1, and 1 plus 8 is 9, and the square root of 9 is 3, and 3 plus 3 is 6. And so we have 1 over 6 as our final answer there. Okay, so step 1, multiply by the conjugate. Step 2, multiply in the numerator. Step 3, simplify the numerator. Step 4, cancel. And then step 5, direct substitution. All right, so that's how you handle the ones with the square roots. Number 12, this is what's known as a complex fraction. Once again, direct substitution is going to cause a problem for us. If I were to plug in negative 2 to the top, I get negative 2. And if I were to plug in negative 2 here, I would end up with 1 over 0 minus 1/2, and that's not possible. And so that's an undefined expression. So once again, direct substitution fails us, so we have to solve it another way. And when you have these complex fractions, the way that we solve it is by multiplying everything by the denominators. I've got two denominators here. I've got 2 plus x, and I've also got 2. So let's first of all multiply everything by 2. So I'm going to multiply this by 2, I'm going to multiply this by 2, and I'm going to multiply this by 2. Now, that cancels those out. So I got rid of one of my denominators there by doing that. On the top now we have 2x, and this now is going to be 2 times 1, which is 2 over 2 plus x, minus, and since these 2's canceled, we just have a 1 left there now. And now I want to get rid of this other denominator, this 2 plus x here. I want to get rid of that. So now I'm going to multiply everything by 2 plus x. And by doing that, this and this cancel. And let's see what we have left as a result. Got 2x times 2 plus x on the top now. And on the bottom, this piece here is just a 2. And then we have minus, and then 1 times 2 plus x. And there we have it. I think we'll go ahead and simplify this a little bit. Let's see what we got here. We have the limit as x approaches negative 2. On the top, I'm just going to leave those apart. I wouldn't multiply those things together. I would just leave them apart like that. But on the bottom, we're going to combine these together. I'm going to distribute this negative 1 in here. And that's going to give me 2 minus x. The 2's cancel each other out. And in this case, the x's will cancel each other out. And we have 2, parentheses 2 plus x. On the bottom, there's still a negative 1 there, though, so we don't want to forget about that. But at this point, I think we're ready to go ahead and plug in and simplify. So if I plug this in, I'm going to have 2 plus a negative 2, which is 0. And 0 times 2 is 0. And 0 divided by a negative 1 is still 0. So the final outcome there is going to be 0. Right? So the trick here is to clear out the denominators by multiplication. And then after that, simplify and cancel. And after that, do your direct substitution. All right. So for numbers 13 and 14, these are the ones where we want to find the value of a that will make this function continuous. Now, if f of x is continuous at x equals 1, then f of 1 should be equal to the limit as x approaches 1 from the right, and also equal to the limit as x approaches 1 from the left. Okay? So let's go ahead and do these things. So f of 1, let's start here. Well, we're looking for the place where x can actually equal 1, and that's right here. So we're going to use this expression, the bottom one, 2x minus 7, and we're going to plug in 1. And so I get 2 minus 7, which is 5. Okay? So that's f of 1. Let's do the next one. For the next one, I'm approaching 1 from the right. And so for that one, coming at 1 from the right means that I'm approaching 1 from numbers that are bigger than 1. So I'm using the same equation here. And so it's actually going to be the same thing. We're doing the 2x plus 7, and we're plugging in the 1, so we're still going to get 5. And then for the last one here, we're approaching 1 from the left, which means we're approaching 1 from numbers that are less than 1. So that's this piece up here. And so we'll be using that part of the equation. So we have a, and then we're going to replace the x with our 1 there, minus 3. And so that leaves me with a minus 3. Okay? Now, this part's kind of unnecessary. We don't really need that for these types of problems, just so you know. All we really need to do is do these two to get the solution. At this point, we just have to solve for a. So I know that a minus 3 has to equal 5, and therefore that would mean that a has to equal 8. All right? So basically, you could probably just skip this step, even though that's usually what you're supposed to do when you do continuity. But for these types of problems where you're trying to find the missing letter, you can do the limit from the left and the right only and just make them equal each other and solve. All right, let's go ahead and take a look at the next one. So the question here is this function continuous at x equals 4? Okay, so once again, this is going to be handled actually quite similarly to the last one. It's just the final way we answer it in the end is a little different. But if f of x is continuous at x equals 4, then we know the following things would have to be true. F of 4 would have to be equal to the limit as x approaches 4 from the left and as x approaches 4 from the right. Okay? So f of 4. Let's start here. Now this time, unlike the last problem you're finding the missing number, this part is necessary because we're trying to prove that it's continuous. So if you're trying to actually prove that it's continuous, you have to do the f of 4. So the f of 4 is the one where you have an equal to 4, and so that would be this piece, 2x plus 2, and we're plugging in the 4, so that's 8 plus 2, which is 10. Next one, we have approaching 4 from the left. That's where x is less than 4, so for that one I'll be using that piece, 5x minus 10, and once again we're plugging in 4. 20 take away 10 is 10. And then lastly, we have approaching 4 from the right. That's this piece where x is greater than 4. Well, this is supposed to say greater. I'll fix it on the worksheet. So in that case, we use that piece there. And so that's going to be 2x plus 2. And once again, that's 10. Now notice how all three of these are equal. So if f of x is continuous, then all these things should be equal, and they are. So check mark. So the answer is yes. It is continuous at x equals 4. And actually, we shouldn't say it. This, on FRQs, the word it is a no-no. We should say, yes, f of x is continuous at x equals 4. All right, let's do another one like that. This is going to, by the way, these are your free response portions of your exam. Okay, for this one here, this is a special kind of piecewise function. The first thing we want to do with these ones is we want to rewrite them a little bit. Okay, it says x equals 2, right? And when x equals 2, we have an 8. But it says anytime x is not equal to 2, that means for anything else that's not equal to 2. In other words, if x is less than 2, or if x is greater than 2, then it's this guy. So that guy's going to go on the top, and he's also going to go on the bottom. Okay? So when you see these kinds that have a little don't equal to thing here, then that's how you're going to do it. You want to start by rewriting it. So if f of x is continuous at, this time we're doing x equals 2, then the following things would have to be true. F of 2 would have to be equal to the limit as x approaches 2 from the left, and as x approaches 2 from the right. All right. So let's first of all find where f of x, where actually x equals 2. Now that's going to be here, which is 8. So this piece right here is 8. Now on approach 2 from the left, that means where x is less than 2. That would be this one, and therefore that would be this piece on top. So we have x squared minus 3 times x plus 5, and we're plugging in the 2. So 4 minus x plus 5. So that's negative 2 plus 5 is 3. So we've already got a problem. These are not equal. Okay? I'm going to keep going because it'll help me answer the question in a final sort of way. So let's keep going. We want to now approach 2 from the right. So that means where x is greater than 2, and so that's this one here. And so we're actually going to get the same answer here because it's the same equation and we're plugging in the same numbers. So I'm using the same equation, still plugging in 2, so I am going to get 3. So here's the thing. The limit from the left and the limit from the right are the same, so that means that the limit exists. The limit as x approaches 2 from the left and the right is 3. Okay? It exists. But f of 2, even though it exists and you get 8, it's not the same thing. So this thing is not equal to those two. So we would say that in this case the answer is no, since this. So is this function continuous at x equals 2? The answer is no, because the value of the function is not equal to the limit at that point. All right? Let's go ahead and take a look at another one here, our last one, number 17. All right, so if f of x is continuous, and this should say at x equals 3, then f of 3, same thing, should be equal to the limit as x approaches 3 from the left and as x approaches 3 from the right. All right. So where can I actually equal 3? That would be here, so that would be this piece. So that's 2 times x minus 3, and x is 3. So that's 6 minus 3, which is 3. Next one, I want to approach 3 from the left. That's where x is less than 3, so that's this guy. I know it's on the bottom this time, but that is this guy down here. So we're using that same piece, and we're plugging in the same value, and so we get the same answer. So far those things are looking equal. That's good. Lastly, we have approaching 3 from the right. That's where x is greater than 3, so I'll be using this guy. That's ln of 3 minus 2, which is ln of 1, which is 0. And those are not equal. Now, even though the function is equal to one of my limits, the two limits don't equal each other. And when that happens, that means the limit does not exist. So for this one, we would say no, since, now there's two ways you could say it. This is the easiest way, because it requires less writing. Or you could say, this might make a little more sense to you to write this. This is another way of saying the limit does not exist in this case, by just saying that the limit from the left is not equal to the limit to the right. You don't need to write both of those. You could just do this one, or you could do this one. Either way is fine. Okay? But there it is. So that's our FRQ question. All right, so how are you guys going to be graded on this stuff? Now, I'm going to give basically 4 points for these. So like you get 1 point for finding f of 3, 1 point from the limit from the left, 1 point for the limit from the right, and then 1 point for your answer with your explanation. So 4 points, and that's kind of how they'll be distributed, so you can kind of see how you're going to be graded. But other than that, we'll wish you guys luck, and we'll see you in class. Have a good one.